All right, hello everyone. My name is Adam Thompson. I'm one of the TAs for ESET 219. Today, I'm just going to be going over some of the basic tips and tricks for using Quartus. Um, Quartus is a very interesting application. We're going to use it all semester to do our labs. Um, it has some interesting quirks to it that you'll learn along the way, but part of today is going to be going over what you should do, and hopefully we'll get into some of the errors and how to fix them so that whenever you get into doing your stuff, not only are you able to do your labs quickly and efficiently, you're able to actually debug things on your own without needing the help of a TA. So refer to this video at any time that you want. Hopefully it'll go over everything that you'll need to know. So let's get into it. So we're going to start with creating a new project. So we just open Quartus, and we're going to go to New Project Wizard and come in here. And now we're going to name whatever our project is. So for just this example, we're going to call this Lab 1. And I would recommend you also split your projects into tasks. So something like Lab 1, Task 1. So this kind of brings us to the first really important thing about Quartus. Whenever you're naming anything in Quartus, the first character cannot be a number. So, for example, this could not be 1 lab. That wouldn't work. It'll give you an error. It'll not be fun. You'll have to remake your project all over again. Don't do that. You could also have no spaces, which is why I have an underscore here. And you can have no special characters, so there's no need to make it a password and add a $sign to the end. It won't even let me do it. You know? So, next thing is selecting the right directory. Now, it defaults to this. This is where you actually installed Quartus. You don't want to make changes there. That's a bad idea. So, instead, what we're going to do is we're going to go somewhere else. So, this is just a desktop. I have an ESET 219 folder here, and I have this Lab 1. So in Lab 1, I'm actually going to create a new folder. I'm just doing this with you guys. You guys wouldn't have these files in here yet, but I'm going to create this new folder, Lab 1, Task 1. So I would recommend for each of your tasks that you create your own folder for each task. So each task, each project should have its own folder, okay? This separates things out so you don't have any overlapping variables in your projects, and it will save you a lot of hassle down the line if you just make a new folder and a new project for every one of your tasks. So I'm going to select this folder. It's going to change here. And then we're going to move on. So we're going to make an empty project always. You can just skip this screen because you're not adding any files. And so here we get to picking the board. So picking the board is important because we use a very particular board. So you have to find it in here. So if you drag this down like I did, it makes it much easier to see all the stuff listed in here because there is a lot of them. So we're looking for a very particular board in here. And so they are kind of in an order where there's 10M50, and we're looking for this one here. 10M50 DAF 484C7G. This is going to be our DE10 Lite board. It's going to have all the right pins on it. It'll be able to load things to the board perfectly. This is what you want. 10M50 DAF 484C7G. A lot of what I see people do is they get this last part right, but they miss this. Make sure it's the 50, make sure it's DAF, and make sure it's C7G and not C8G, because C8G will not work. Just keep that in mind whenever you're picking things. All right, so now that we're in here, we're going to just change this simulation over to custom and then VHDL. So this will make it work with our actual simulation software that you guys downloaded. All right, and then we're going to move into this next page. We're going to make sure all of this looks right. It does, and we're going to hit finish. All right, now that this is done, Our first step is usually going to be we're going to create a block diagram schematic file. This is kind of, well, your basic building block for all of your programs. So we're going to click block diagram schematic file. We're going to click OK, and then we're going to get a screen that looks a little bit like this. There's not much in it. So let's kind of start with what we have along here that we can do. So let's start with this. This is the symbol tool. So you can use this, you can click on it and insert symbols. You can also double left click. When you double left click, you can also pull this up, a little bit of a shortcut. And here you can put in gates. So you would look up a gate, it would be something like and 2. And you can get an and 2. You can get it. Don't use this. Don't use and 5. If it looks like this box looking thing, don't use that. But for example, and 4. So we would hit OK. And then we get to place this block in here. Now, a few things that I want to note about this block as we start out. It's got its name at the top here, and 4. It's got these 4 input lines, and it's got an output line here. And at the very bottom, you see something called an instance. So part of VHDL is that all of these blocks have an instance number. They all have a unique name. Basically, my name can be Adam Thompson, but your name cannot also be Adam Thompson, or the universe would get really, really confused and it wouldn't work anymore. So for that reason, all of these have their own particular instance names. So if I Control C, Control V, and I have this other instance, now we're going to get an error in the future, and I'm going to show you how to fix this error. So the next thing that we have in our bar here is we kind of continue with what we can do, is we have these pins. So these are going to be our input pins, and our output pins, ignore these. So input pins are going to be all the inputs to your program. They're going to be those variables that you're using. So, and we can create them all just by going like this. So we have 3 here. You can move these around with the arrow keys, by the way, just to organize your stuff. So something like that. Why are you longer? Anyways, doesn't matter. So with this, what we can do is we would have these all inside of this. So we have, what is going on here? Okay, whatever, doesn't matter. So we have all this. Now, something that I always do is I always set up my stuff stacked vertically. Now, this will cooperate with me. Come on, Quartus. There we go. So usually your pin names are going to be something like X, Y, Z, A, B, C, something like that. But you see what I just did? I was able to label those all really quickly. I didn't have to double click through all of them and figure them all out. If you have things stacked vertically and you're making a change to a certain field, so say the actual name of this from X, and I actually wanted this to be A, B, C. Because these are all stacked vertically, it's really quick to change those by just hitting enter. So stack things vertically would be my recommendation. The next thing I would say to do with the beginning of any of your projects is you're going to pull 2 wires out of here. You're going to pull 1 wire that looks like that, just straight out, and then we're going to put in another gate here. Right, this is going to be a NOT gate. So NOT doesn't have a number next to it. It does not need one. And then we can come in here and we can actually, if you hover over the ends of one of these inputs, you'll get this little symbol here. So this is your wire tool. So what you're looking for with the wire tool is just to click and drag. It only will make 1 turn as you go. So you can't do super crazy smart lines, unfortunately, but it works for the most part. So we have that, we have this, and now we have these 2 things. So immediately what this is doing is we're creating a line that is just A. It is just whatever the input of A is, whether it is a 1 or a 0. And then we have a NOT, which is just going to be the opposite of whatever you have. So what we can do here is actually highlight this, do some fun Control C, Control V, and I can use the arrow keys to actually line all this stuff up like this. And then whenever all of this is aligned, now I didn't have to make this over and over and over again. So that's fantastic. So now what I can do is actually this. So I'm going to get rid of, I'm going to just select this wire. And this is going to be something called virtual connections. So virtual connections is a way that we use in Quartus to not have to draw a ton of wires. Because if I wanted this input here to be A, I would have to drag this all around, line it up, and then get this over here. And it takes time. It just takes a lot of time to do this, and especially to make it look nice. And it's going to get even worse when you have a ton of stuff to do. So not only does it take a bunch of time to drag these wires around and make them look nice, if you mess something up, like this is accidentally not supposed to be A, it's supposed to be A naught in your equation, you then have to like select weird parts of your line, delete them, get them to go in the right place. It becomes very difficult. And especially when you're debugging, or especially for your TA when they're helping you debug. So the easiest thing to do is instead use these virtual connections. So what I can do here is to make a virtual connection, you're going to need it to be a name of something. So you just select the wire and you just start typing. So I'm just going to call this K. And then I'm going to select this wire here. And we're going to call this A naught. So now if I name any other wire A, this wire, this A here, and this A are connected, and all I had to do was select the wire and start typing. Be careful of adding spaces to any of these on accident, because it will give you an error in the future. But you can go through and you can change these, and you would name this B, B naught, C, C naught, and then you would just have those for the rest of your program. And that's actually going to do a lot of work for you in the future, just setting up your project correctly in the first place. So now that I have that, oh, another fun thing. If you have virtual connection wires and they're stacked vertically like this, you can hit enter to tab through them and change them if you needed to, which makes fixing some issues that you have with your program, because you're eventually going to have an issue with your program, much easier. So last thing we need, so we have now made input, we have some logic, not much, it's just A and nothing does, well, nothing right now. Now we need some output. Oh, I'm just going to have some output over here, and we just get that from the little pin bar, and we'll just have, we'll do 2 outputs. We'll be fancy, why not? So, and all we would do is just connect these here. So if you are going to do wired connections, make sure that the little box you see right there actually lines up, because if it doesn't, you might be just a little bit off in your placement and the wire's not actually attached. So that can cause some really hard to see errors in the future if you don't make sure that box is there. So then I can move this around as well. And if I move this and I can see the wire moving with it, I also know it's connected. So that's a way you can kind of check if that's working properly. So now I have some inputs and I have an output. So what I'm going to do is this and this, and then I think we should have enough logic to do what I want. I'm just going to do this really quickly just to make this an example of sorts. So here we see that there's actual dots along this. So dots are another part of the wire. These are intersections. So if you have overlapping wires, so if I were to put this wire to here, that didn't work. So if I put this wire to that line, see, I didn't wait for the box, even I do it. This actually creates a connection. That dot indicates that these 2 wires are connected. And this actually can't happen. And I'm going to show you what happens whenever you do this in a moment. So whenever this happens, you actually have two different signals going to the same wire, and we're not doing quantum computing. We can't be multiple values at the same time. We're doing binary. So if it's this A, it can only be this A for all of them. So attaching these is going to give us an error. And that's something you got to look out for and check to make sure your dots, whenever you're using wires, are in the right place and you don't have extra ones. So we're going to now, well, let's go through the last bits of this. So these are your wire tools that you can use. Don't use the buses. There's no point. You don't need to use them. So if you wanted to just make wires, besides hovering over things, if that's kind of hard for you with your mouse, your sensitivity, whatever, you can use this wire tool here to actually create these wires normally. So now we're going to do our first save of this, and we need to make sure this is some name that we want, something like that. So part of what I did is I made this name here different from the name here. This is a very important part of using Quartus. This is your project navigator. Now, your project navigator allows you to do a whole bunch of things. So whenever we get our project navigator, we have hierarchy and files. Hierarchy and files are two of the ones that we're going to go through. You don't really need to worry about the rest of them. So in hierarchy, we see what we're going to compile. And basically, when you're compiling things, you're turning this visual code into actual VHDL code that's going to go onto your board. It's going to do all the fun flashing lights and switches and everything we need you to do in the lab. If this name here is not the name of the thing you were trying to compile, it's not going to work. It's going to give you an error. And so to fix this, what we can do here is we can right-click, if we're in files, we can right-click on this and set it as top-level entity. Alternatively, if we're in hierarchy here and we don't want to switch over and we have the tab that we want selected, the file that we want selected to be the one that we're compiling, you can go to project and set as top-level entity as well. See, now this name is the same as this name, so when we compile stuff, we're actually compiling the thing we just made. So, how do we compile? We're just going to go here to this little blue triangle. We're just going to hit like start compiling. Now, this is going to give us an error, and then we're going to go over what that error is actually doing. All right. So now that that error has come out, we can see that we have an error here. So this is the first one that it gave us. So we know we have two, but this is going to be our first one that we're going to deal with. So this is an instance error. So if you can't see this, sometimes if your window is too small for this, you won't see the name of this. It'll look probably something for you guys a little more like that, just that you have an error. If you want, expand this at the beginning so you can actually see the list of them. But this is an instance error. This is pretty much the most basic error that you can have and the easiest to fix. So here we would just go to instance. You can double click on this, or you can go to its properties by right clicking on it. And we're just going to change this to some random number, something like that. So that way it has a unique name. It doesn't have to be something special. In fact, I would recommend you just hit buttons randomly until you get something unique. So this will fix that error, because now you definitely don't have an inst, whatever that is. So we can just compile this again, make sure we save our changes, and keep going. This is our second error. This is that error I told you we would have with this. Signal A drives an input pin, which is basically saying that A is going to here, but it's also giving data back into B. So we can't have that, because remember that thing that we said about binary earlier. So we would have to break this connection. So when we break this, that'll fix it. So we have to make sure that we don't have wires going to the wrong places, which is why virtual connections make things much easier to work with. Because then you don't have to find that one weird dot in your sea of dots and your jumble of wires that can be created. And then it's much easier for you to fix things. So now that we have that, I'm going to compile one more time. All right, now that that compiling is complete, we actually have this as something that we could test and simulate if we wanted. So I'm going to wait to go to simulation first, but we're going to get into something called creating blocks. So to get into creating blocks, we're going to create a new block diagram or schematic file. So these blocks, these schematic blocks or functional blocks are, if you have experience with programming, they're just functions. They're pieces of code that you create in another spot to put back into your code that you can replicate over and over and over again. So if we wanted to have something in here for, say in lab 3, you're going to create in lab 3 a whole bunch of equations that do 3 different things in the end. So for each one of those 3 things, you could make a separate functional block and then have something like a main, something like this, where instead of having a bunch of AND gates and OR gates and NOTs and stuff, you basically just have these functional blocks and all of your work goes into the functional block. So your logic would go in here. You would have, again, you would put in inputs, you would do your logic, you would have AND gate, or you would have some logic, and then it would give you some output at the end of things. Okay? So we have approximately logic here. Yeah? That was there. And there. So this is logic. Not very fun or cool, but it's logic that we're going to create a functional block out of. So you just create your inputs and your outputs as normal. And the big thing is usually in functional blocks going to be your logic. One of the best things about functional blocks is that when you edit them, you don't have to compile them. So you can create a bunch of edits, and then all you have to do is just save. And we can save this as block 1. And that'll be its name. So block 1 here, all I have to do is save this whenever I make a change. So if I just did this, doesn't change the logic, but it changes something, and I wanted to update that in, if I had this block in here, all I would have to do is save it. This makes it really easy to debug because the compiler, whenever you get an error, it'll tell you, oh, it's also in this block. So you have less looking around for instance 200 of AND gate 4 to do. You just go, oh, it's in this block. It should be, oh, there it is. And that's the end of it. It makes things much easier. So I highly recommend using functional blocks, at the very least, just to organize your code. And it's a good practice because it teaches you how to make functions and will be useful in later classes that you take. So we have this logic here. How do we get it into that functional block that I've been describing so frequently? So all we need to do is we have this here. We're going to go File, Create Update, and Create Symbol File or Current File. Here, it's going to give us this name again. And we're going to save it and make sure we're saving it in the directory that we made the project in. Make sure it's not in one of these folders, okay? So we're going to save this, and we've created this block. And now we can actually check in here in Files and see all of the files we have associated with our project. That looks good now. And so how do we get this block in here? So what I'm going to do is I'm going to double-click to open the Symbols tool, and I can just look up block 1. And I get the block I made with all the pins and the names that I want, and I can just attach some logic to this if I wanted, and have another output to work with. So that's how you create functional blocks. Usually, they go in as just inst, which can cause problems. So I would check the instance of any blocks that you've made and put in before compiling. Just update the instance so you don't have to wait for compiling to tell you that you have an instance problem. So, fun tip. Oh, I'm going to take this out of here just for ease of working with things. And then we can move on to actually creating waveforms. So to create a waveform, what we're going to do is we're going to go in here to a new file, and then we're going to go to University Program, and you're going to hit OK. So here you get this new window. This new window is going to be where you're going to create all of your waveform stuff. So first we need to get our inputs and outputs actually into this. And I'm going to come in here and just double click and just going to pull up insert node or bus. So we're going to go to our node finder. We're going to list them out, and you can either select the ones you want, or you can just hit this and move them all over. And then we're just going to hit OK. And OK again. And now we have some inputs and some outputs. So you can see what they are here. And the outputs should usually look like this crosshatch pattern. So, few things first about what this is. So these wires basically represent whether the signal you're sending is high or low. And this is for simulating your circuit. So this is going to be very important for checking your work, especially when you're not in the lab and you're working on something outside of lab. So whenever it's this low here, it's 0. Whenever it's this high here, it's 1. So we can change this, and you can double click spaces like that, by the way, to make things a little faster. And you can force high and force low. Now, this is kind of the basis of everything. You can create numbers with this, binary numbers, through forcing things. It's not the way I would recommend doing things, but you can do it this way. The way I would recommend doing things is actually grouping. So that's what we're going to go over right now. How to group things together, how to make this go a little bit faster and is a little bit easier. But if you wanted to, again, you can just force things to be what you want, and that is perfectly fine. So, grouping, though, is faster. So the first thing about grouping is we're going to take all of these and we're going to put them and basically make them into one thing. But before you do, make sure that your MSB, your most significant bit, is at the top of your group. So I'll say that again. Make sure your most significant bit is at the top of your group and your least significant bit is at the bottom of your group. Now, if that doesn't make sense to you right now, ask your TA, wait for Dr. Porter to explain it, Google it. If it does, awesome, you know what that means. But make sure your MSB is at the top, your LSB is at the bottom whenever you're creating a group, or else you're going to get a backwards number, which is usually not what you want it to be whenever you do these next steps. So I've just selected these, and I'm going to go to grouping, group, and we're going to call this in, just an input. And we have this other option here. We can keep it in binary, or it has all these other options. Pretty much the only other one is this, unsigned decimal. So I like to do unsigned decimal because even though this is a binary class, reading binary can be hard sometimes. So working in unsigned decimal just makes it a little more easily graspable. Now, I'm going to go with unsigned decimal here, and we see this is now this big group. So now that we have this group, all these are grouped in here, I can make changes, all three of those numbers at the same time. So if I force all of these high, it becomes 1, 1, 1. And so for this interval that it's showing me here, it is 7, or the number, the unsigned binary value would be 7 for 1, 1, 1. Okay? So that works that way. So another thing that you can do, and the thing that you're normally going to do in a lot of these cases, is you're going to start by coming over here, and you can do this. You can select the whole line, and then you can right-click and go to Value, and then Count Value. It looks like a little fish with a C in its mouth. So you can come here and do count value, and it'll pull up this window. And so you can set a start value, you can set what you're incrementing by, it's usually going to be 1, and then you can set your count every. Now don't keep this count every at 10. That's usually really, really hard to read. What we're going to do instead is you either set it to 100 or you set it to 50. You can set it to more, you can set it, I would not recommend setting it to less, but 100 or 50 nanoseconds is usually the way you want to go with all of these. It just makes things look pretty. And it's easy for us TAs to read, so if you get your work right, it's much easier for us to say yes. So here we get all of the counts we can do with a 3-bit number, which is just 0 to 7, then it goes 0, 1, it starts counting over again, but we don't care about that. We just want to have a full count of this. Now, this works incrementally through all of these super quickly, so you don't have to be the one to set all of this up, and it's all at a consistent interval that we set. Beautiful, perfect, awesome. So, this brings us to what do we do if we don't want to just count? What if I wanted to put in particular numbers at particular points to test a particular outcome? Well, what you can do is this. I would always recommend starting with a count, simply because it puts you in this already nice increment, and everything is nicely spaced out in the first place. But if you want those arbitrary values, I'll use the right term for it, you can come here after making your count and do value, arbitrary value, the question mark. Or if you're doing a lot of these, remembering Control-Alt-B is actually a really good trick. So we come here to arbitrary value, and I can change this 1 to be whatever number I want. So if I want this to be 5, I can change that value to 5 with arbitrary value, and it becomes 5 in here. 1, 0, 1, the binary for 5. So that's how you put in different values where you want. You can also double-click these, and if you hit the delete key, you can get rid of them. So if I don't want 5 to be down here still, I can count 0, 5, 3, 4, 6, 7. And it'll fix things. And this count over here looks a little funky, but it's okay. We can use arbitrary value to fix that if we even needed to. But I'm rambling. The last thing here would be using the actual overwrite block. That I'm not going to get into right now, but basically it just creates a clock interval at a specific interval and a specific duty cycle that you can use later on in the class whenever we get to actual memory elements using flip-flops and clocks to create memory circuits. So, not something to worry about right now, but the clock is how you would create that interval correctly. So, next thing we do, now that we have all of our inputs set up in the way that we want them to, and we're ready to test the circuit we've made. So we're going to come in here, and I'm just going to hit save. And so whenever you save, again, you want to make sure that where you're saving this waveform to is the same directory that you made your project in. You should see all of these 4 folders. Oh, and by the way, you should not make any more folders in here unless Quartus does that for you. Okay, so just don't make any more folders inside your directory folder. A lot of the times, you guys will have problems wherever this goes to output files. So I'm actually going to save this in output files, even though you should not. Again, you should not save this here. I'm doing this to show you how to fix it in the future. So I saved that there in the wrong place. So what I'm going to do is I'm going to go to simulation settings. So this is the next thing we do. So we save what we're doing. We go to simulation settings. Then we are going to, usually, you don't have to always do this, but this could save you a lot of hassle in the future, especially if you set things up right and save things in the right place. Doing restore defaults at the beginning is a fantastic way to make sure that all of your file pathing is what you want it to be. Okay? And so the last thing we're going to do is once we're in here, we're going to come to this Novo PT here, this -Novo PT, and we're going to delete it. If you don't delete it, you're going to get an error that says Novo PT is in there, and you have to go get it. So always remember, you go to your simulation settings, you change it to VHDL, and you get rid of Novo PT. And then we're going to hit save. Okay? Now, Some of the instructions you have say that you have to generate this models and test engine script. You don't. You just have to run the functional simulation. So we would just hit run functional simulation, hit save again, and this should give us an error. Perfect. So this error here, the important part of it to look at is this test bench file option contains a non-existent directory path. Why that is because this is in output files here, where I put it. It should not be there. So if we get an error like this because you forgot or you didn't think about it, this is how you fix it. So all I'm going to do is I'm going to come in here, File. I'm going to go Save As. I'm going to go, oh, you are in output files. You should not be there. I'm going to go back to our main directory for our project. I'm going to hit Save. Next thing I'm going to do is I need to update my file path again. So I'm going to come in here and do Restore Defaults, switch back over to VHDL, and get rid of Novo PT again. And just hit Save. Now all I have to do is check that again. Run the simulation. It's going to run through everything. And we get an output. Cool. Awesome, right? So we got our output file. This you would take some sort of screenshot of if you were having a report or something. But this is what TAs are usually going to check. We're going to make sure you have the right waveform. And this also tells you, oh, at 5, this was not pin. This one was actually supposed to be off. I have some problem in my logic right there. So using this, you can actually, the simulations, you can actually debug your code. And it works really nicely, in fact. But this, now that you've run this, you see all these grayed out. This is a fancy screenshot. You can kind of interact with stuff. You can make changes to like the radix here. So let's say I wanted this to be in binary instead. You could change it, but it's not going to make any changes to your actual waveform. So I would just take screenshots in this. Don't do any changing of things. It's not going to work out for you. So that's a screenshot. So that's pretty much all of the things with simulations. You can also group your outputs if you want, but remember the big thing with grouping, make sure your MSB is at the top of your group and your LSB is at the bottom of your group whenever you're creating anything. Okay? So that is simulations. The last thing we're going to go over is programming. So whenever we go to programming, we can go to this in two ways. First, there is this tool option, then you go to programmer, which does work, but I like using this. This is the shortcut here, this diamond with the lines coming off it. You can use this to get to your programmer. Here we can program things, but first it's probably really important that I tell you about pins, because if pins aren't assigned, the board has nowhere for the logic to go. It doesn't mean anything. So here we have our pin planner. So this is the pin planner, and this is a good time to check, did I select the right board before putting in your pins? Because if you put in your pins on the wrong board, you have to do it all over again, and it's really annoying to do. So what we're going to do here is we're going to go to location, and you're going to put in pin numbers that you want. You can type these in. Pin number, let's go with like C10. That would be an input pin, and I can come over here to pin A8, and I can assign an LED as an output pin. And you would go through for all of these and assign the pins. Now, where do you get these pin names from? So there's a link to it in Canvas. I believe it's in course resources for the DE10 Lite user manual. You can also just Google DE10 Lite user manual. It'll be the name of the board that you see on the board box. If you just Google that, there'll be a PDF that comes up, and I think it's on like page 27 or 28, where you can see the inputs, the pin names for all the switches, and the pin names for all of the LEDs will be on like the page after that, and eventually I think it's 1 or 2 pages after the LEDs is the um, 7-segment pins, which will be important when we get into the labs that use the 7-segment. Some of the big things that I want to emphasize when assigning pins, especially input pins, when we're assigning them as switches, if it's for the most part what they will be, they'll be switches. Now, when we assign switches as input pins, we don't want our numbers to be backwards, right? It's already kind of hard enough in the beginning to know binary. Knowing binary and then knowing it backwards becomes harder. So we have to think about, in creating this user interface, we read from left to right. So you want to assign your most significant bit. So if A is my MSB, I want to assign this to probably the third switch, so that my MSB is on the left, so I can actually read this left to right. Now, so it's a little bit of a weird thing to think about. Why would I not just put in the pins? I know where they go. Demoing stuff on a board does become tricky when you have your TA standing behind you and it's a little nerve-wracking and you're trying to remember what the binary for 5 is and it's like week 2 and you're like, I should know this, but it's okay. If you assign your pins in the right order, it makes things much easier. So assign pins, especially your inputs, from left to right. Your MSB being on your left and your LSB being on your right. So once we have all of these pins here, what we would do is you would need to recompile everything and you would see the pin names come up on all of this. So when we recompile, it assigns all those pins. You do have to recompile after assigning pins or changing pin assignments. So coming back into the programmer, we have our programmer. It's this box here, or you can go into tools and then programmer, but I like to use the shortcuts because I've been doing this for a long time. So next thing we're going to do is we're going to come into hardware setup. Usually you guys will have something here. I don't have a board with me right now to plug in, so you don't see anything. But basically in this drop-down menu, you're going to see a USB that you can select. If you don't see this, get your TA, they will help you. And you basically just need to install a driver. If you've looked at some of the material that we have, it explains to you how to install that driver. I'm just not going to be showing you how to do that in this video. But you would have something there. You would see there would be some resource here that you could do, and this button for programming would become highlighted. So all you would have to do now, if your board's plugged into your computer, you see everything here, this button is no longer grayed out, you just press start and this progress bar will fill up to 100% here, and then you have your program loaded onto your board and you can do all your testing, you can show your TA, and then you can leave, and then you're done with lab. So that's perfect. That is it for all of kind of my tips and tricks. The big things to remember: naming conventions, no spaces, no special characters. Don't start a name with a number, it won't work. Remember your instances. Use virtual connections. Virtual connections are very, very good. They simplify a lot of your tasks and they make debugging so much easier. I promise you, use virtual connections, your life will be easier. All right. That's it. If you have any questions, email your TAs and they will help you out with anything else. Thank you.